Hello everybody, welcome back to the channel. This is Michael, KE4EST. And you can see on the bench here today we have a night capacitor checker, what they're calling it. Real simple device, got some dust on it there. I'm going to clean it up. It's got one of the magic eye tubes in it. I believe it's 6E5. And it's a real simple circuit that's got, but the thing about this one is you can test, it doesn't say it on here, but you can test capacitors in circuit. And this right here coming out of it's a piece of coax. We'll look at the schematic here in a minute, but then you got these test leads, these original ones that came with it here. Let's see if I can salvage those. Somebody's really got some kind of weird boogered up mess going on here with this. You can see, and black tape, it's coming loose, and who knows what it looks like. And it's kind of hard to show it in camera, but I can tell you right now it's not 48 inches long. This uses RF too, so you can test capacitors in circuit. It's got, an oscillator running in there. And this is part of the circuit, so this needs to be, and the manual calls 48 inches. It needs to be 48 inches long, and it needs to stay 48 inches long. It needs the right kind of coax, and so on and so forth, because this acts like a 1/4 inch stub at the frequency that it's running at. So that you can take this and reach in, a circuit with, of course not an energized circuit, but one that's been, you got to unplug and capacitors properly discharged, but you want to check your capacitors, you can just really quickly, and you really don't have to clip it on there either. If you got this down in test mode, you can just stick it across there and stick it across that one and watch this eye, and it'll tell you in the open test. Now in the short test, like now it's down in the short test here, it really doesn't use the oscillator. For a short test you can still use a regular old multimeter or something. Take your VOM meter, whatever, use and check for resistance. Now if it's resistance, it's going to be, even in circuit, if there's some other resistance in the circuit, it's going to show a really low resistance, a few ohms, and you'll know, well, that capacitor's got to be shorted. Because even if you take a circuit, proper circuit, just say a test circuit, and it's got a 100 ohm resistor in it, and you got another resistor or a place for resistor, and you just put a shorting bar across there to short it, what's it going to do? Take the least path of resistance. That's what the circuit's going to do. So it's going to show shorted circuit even though you got the 100 ohm resistor in there, if it's parallel across with the 100 ohm resistor. So that's what this does. It's kind of neat little circuit. Not a whole lot to do these things, so it's it's neat. The neat thing to have this, one of these, is to use it for checking for capacitors in circuit, for open capacitor, shorted capacitor, to see in the open mainly. If it's you want to see if that capacitor is open or not. And in most cases, they're going to fail shorted. That's just the way it is, but you can really run through this really quick. If you got 2 or 3 ohm meters, you can put an open test, run through it, put in a short test, run through it, as long as that eye is closed every time you go across the capacitor. And either way, because we'll go, like I said, go over the schematic here in a little bit, but the way the schematic's set up and the way it's set up, this is going to, or the way the circuit's set up, it's designed so that in the open or the short side, a good capacitor, and it shows you right here on the front, is always going to close the eye. If it stays open in either one of these tests, it's going to be, eye's going to stay open, so something's wrong with that capacitor, right? So to get into this thing, it's got this little leather carrying handle on top. It's still there, and these things come out in the mid-50s. So this is what, 65 years old or something like that. It's got these screws in the face. You can see I've already taken them out. Around here there's 1, 2, 3, 4, 5. And on the back of it, there's 2 screws here to hold it in. So you just take those out, which I've already done. Take it apart and look in this thing. And get this out, quit making all that noise. That's the part I love, is going in these things, never seen it before, and get a hold of it and open it up and see what's inside of it, and see, even if it's something you know what's inside, a piece of test equipment or a radio or something you've worked on before, so you know what's in there or what's supposed to be in there. And that's the fun part, is to see, a really neat part, see if it's all there, see if it's still there, see if it's like it's supposed to be, whatever. I can already see we got the tubes in there, which you could see from the front, but we got this in here, and 6E5, and this is going to be a 6C4. That's pretty obvious, almost. Well, to me it is. Looks like a 6C4. I glanced over the schematic, but I've not really looked at it in a few days. Yeah, it's 6C4, and the socket looks pretty clean. Everything looks clean inside there. But anyway, everything looks like it's up there, up here. So let's have a look at the bottom here, and let me move the camera, and the lighting will zoom right on into this thing. Let's see what we got here. So let's see. There's a big old capacitor there going across from over here. It's probably our filter capacitor. We got one of them older diodes in here. Hopefully that'll still be good. If not, you can replace that with, in this circuit, I was glancing over at the schematic. I got it laying over there. Probably, throw in a 1N4007 or 007, I should say. And then here's our oscillator circuit. You can see here's the 6C4 up here, and then there's one of the capacitors. The other one, 1, 2, 3 in the circuit. Sounds about right. What am I? Okay. Say something's missing. It's not missing. It's up here. There's a variable capacitor there to align it or mess with the circuit. That there shouldn't be touching that. Is that touching that? Almost looks like, no, not touching. Now remember, make sure before you put your hands in anything like this, even this, make sure it's unplugged and everything's been discharged. And we're going to start grabbing things, you'll get lit up. So definitely going to replace this capacitor and this capacitor here, and that might be it. That might be the only thing I have to replace here. The resistors all look like, well, that one's definitely Allen Bradley. Let me reach over here and find my spectacles here. Now that's Allen Bradley style, so that one's probably good. Don't mean it's going to be good, but that one's Allen Bradley. Let's see. And there's our diode in the circuit we'll get to in a minute. Another diode. Wait there. I got it too zoomed in, don't I, here? Another diode here. Look a little different than modern diodes. 1N51. That could be replaced with even something small, probably 1N4001 if it needed to be. You can see here's where the coax is coming in here. They did an okay job there putting it in there, but the other end's probably, somebody's boogered it up later on down the line, to try this thing out or something. But you can see they didn't replace anything in it. Everything looks like it's probably about 65 years old. There's 2 resistors down there that I see. Am I missing? No, there's another one. Allen Bradley style. And up here, yeah, feel like I'm missing a resistor. But anyway, and you know, with these resistors, let me get a meter out here. Something I can just put in the shot. I don't know if we can put that in the shot or not. This resistor here, it says yellow, violet, black. So that's 47 ohms. What I was going to say, a lot of these, this cheap stuff, you can test them in circuit. Look at that, 46.7. That's good enough. This one here is 47K. My hand's in the way, ain't it? 44K is what we're showing there. That one I may have to check. Probably still be fine in this circuit though. Some circuits are more critical than others. Oh, look at this. Let's see. Let's just move that out of the way. See that resistor right there? I don't know. Let me see if I can zoom in on that a little bit. Not too much, I guess. See that? That's what's called a roundy. It's got one of them stuck in there. They call them roundies. This is what we call them. Those are bad to get moisture ingression and not read properly. Let's see if I can figure out. It looks like 470K. Let's see, that's across the switch. There should be a... Yeah, okay, that's looking at the schematic here. Yeah, it's supposed to be 470K. Now this I may not get a good reading on because it's right across this capacitor. If that capacitor is leaky, 470K. I know you can't see the meter right now, but I'm getting about 427K. So yeah, we're gonna have to replace that one. Of course, it could be this capacitor dragging it down, but it's also a roundy, so it's like, a lot of times I see those roundies like that, I change them out. You don't have to. If like you check 1, 2, 3, or 4 roundies in the circuit and they're all testing okay, and it's been okay for this many years, they'll probably still continue to be okay, but it don't hurt to change those out. But yeah, that one's reading a little low. It could be if I take this off and solder this capacitor, it may read properly. This capacitor being probably really leaky by now is probably having an effect on that. But anyway, there's that. And this meter out here. I have the shot, and let's look at the schematic for a minute here. Now let's do this. See that schematic. I actually have the book on this one. It came with the... I come across this one. It came with the manual for it, and it even come with a big fold out, but it's not a big fold out of schematic. It's a big fold out of, assembly, because it's a night kit. So somebody put this together. So it goes through in the book and tells you how to put it together and where to solder what to and what order to put everything in. And then that big fold out, I've got it over here. It just shows you I've kind of got things zoomed in here, but it just shows you how everything should look and where it should go and everything like that on the different parts of the chassis. So there's that. So let's look at this schematic here and have a look at it. So what's going on here? Over here you got your standard, your transformer, your power coming in, rectified here, going up and feeding voltage to the plates of the tubes. But really what we want to look at here is how this here is working here. And if you look here, this 6C4, and in the circuit here, This is basically a Hartley oscillator. You know, and so I mean, if you want to get into Hartley oscillators, you can look it up. I don't want to make the video any longer than it's going to be anyway, but got a basic Hartley oscillator, LC oscillator here, with this coil and this capacitor, and we can adjust it here. L2, what it's doing is coupling off of L1. Okay, if we look real quick again here, this is L1 here, and here's L2. Okay, I'm just using this to prop this up with here. So this L2 is coupling off of that, and this oscillator is running here. And the manual, I think, says something around 20 megahertz, 20 megacycles. So with that circuit, this is coupling off of that. And with C5 and L3, then we got the C6 coming to ground, off ground here on this side, and it's coming through. This switch is in the open side, and it's going into this piece of coax, which is cut at 48 inches to match this circuit. So this is acting as a quarter wave stub. So remember, this is RF, not DC. So in this configuration, if you leave the test clips open or put it across a good capacitor, because you know I keep saying that, but just remember, this is RF. So you leave these open. With them being open, now here's ground, but we got this quarter wave RF stub here, you know, with this circuit here. It's going to appear to this circuit on this side as a short circuit, right? So what's it going to do? It's going to give us voltage right here. It's going to think it's shorted out, so it's going to cause a voltage here. You see the way this diode's oriented. You know, this is, you know, AC. You know, it's oscillating, you know, back and forth, a sine wave. We're just going to get the negative side here, which is going to put a negative voltage when this, you know, this being a test position, this is in the open position, and it's going to put a negative voltage on this grid, and it's going to cause that eye to close, right? What does it say here? If it's good, it closes. So if you leave the test leads open, well, that's not want to stay, does it? Or you put it across a good capacitor, which is not shorted, what's it going to do? It's going to stay open. Now if we flip it the other way, well, that thing won't stay. Alright, so maybe I'll clip some of this out. This thing's falling here, but I didn't think it was going to take me this long, but I feel like I want to get it, you know, across to you how this thing's working. Okay, anyway, so if we put this down to the shorted position, I'll just hold on to this thing. Shorted. Okay. This, you know, it's a double pole switch. It's going to flip to shorted. So now, you know, this part's not going to be in the circuit anymore. We're just going to have this right here, this resistor and this capacitor. Okay, and we're going to have this voltage coming off of this, the tiny voltage here, AC voltage coming off of this filament side, this transformer here that feeds filaments. So we got like 6.3 volts coming here, and then we got this resistor into this circuit. So what's it going to do if we put it across a good capacitor? You know, this is clipped in across a good capacitor. What's it going to do? We got the same thing here. So this is going to come on through here and cause, you know, the AC voltage will self-rectify, and it'll cause that eye to close again. So like it says in the short test, it's still going to close the eye. Now if that capacitor's shorted, okay, remember our test lead now is just so you ain't worry about if it's coax or not. It could be just two pieces of, you know, test leads. We're going to short it out here, and that is going to go, remember it's coming up through here, so this is all shorted out, so it's going to short this across this resistor. We got to have a resistor here, so we have a dead short from this transformer and burn our transformer up, you know, or cause too much current to pull and trip a circuit or something, or blow a fuse. This ain't got a fuse in it, but so that's what that's there. It's going to put it across the load there. and the eye's going to stay open. It's going to dump it across this here. This will be our load, and that eye will stay open. And then you take it off out of the shorted position. It's going to allow it to come on up through here and close the eye again. So I hope I explained that to you okay. I hope you got that across. It's, you know, pretty simple circuit, but it can get a little crazy because if you're used to working with all DC circuits all the time, it looks a little like, how's that doing that? But just remember, if this is open, RF, and the RF side, it's going to see it as a short. If this is shorted, it's going to see it as an open. It works a little bit different, you know, because it's RF. As long as everything's right and proper in the circuit, and this don't deviate too far from 48 inches, and it should work like it's supposed to. But I get the capacitors changed out and fire this thing up. Maybe change that one resistor out. We'll go over that and look at that and see, and I'll show you. We'll show it. You know, you can probably see it a little bit better if I show it to you in operation with, you know, some resistors, and you know, I even use some resistors or clip the leads together, show a bad capacitor, a good capacitor, and we'll look at that and see. So in the next video, in part 2, I'll come back with it all nice and done, and we'll test it out and see what she looks like. And until then, this is Michael, KE4EST 73.